actually a wind. It doesn't carry with it the same force as a wind would down here on Earth. How a solar sail works is actually using the power of light. Now, believe it or not, light actually carries with it some force. You go outside, you get hit by sunshine, it actually hits you with a little bit of force. It's not enough to knock you over or anything like that. It's a very small amount of force. But in space, you can actually take advantage of this force of light. A great example is, let's say you left a flashlight out in space, and it had unlimited batteries, let's just say, and you left it on, and the light was shooting out in this area. Well, the light going in one direction actually carries with it some force. It would actually move the flashlight in the opposite direction. It would be a light drive. And that's sort of the idea around a solar sail up in space. So I have a little model over here, and a solar sail up in space uses a very reflective surface. So something that would reflect light. And again, it would be like that sort of a mylar material, or say you wanted to build one at home, aluminum foil. And the idea is that when light hits something that is very reflective, it is going to bounce off. It's going to bounce off. What a photon will do coming from the sun is carry a small amount of energy. When it hits this reflective source and bounces off, it actually gives a little bit of its energy to this sail. Now, out in space, what ends up happening is that if this was left in the path of our sun, over time, every single one of those photons would start to speed this up. And the idea being that, if this was a photon out in space and it hit that, it bounces off, but it gives a little bit of energy in this direction. Now, not very much. That really didn't give this much energy at all. But out in space, we don't have to deal with factors like friction or gravity in that same way. So it doesn't have to worry about rolling on the carpet. It doesn't have to worry about air resistance. So over time, a solar sail, getting this free energy source from the sun, would start accelerating faster and faster and faster and faster and faster. And this is just by putting the thing up and popping it open. Now, again, it's not going to speed up like a rocket would. We're talking about the difference between, say, a smart car and a drag racer. A drag racer is going to go really fast right off the bat, but it's going to run out of steam very quickly. A smart car is going to go really slow, but it's going to go for a lot longer. And that's kind of the idea behind a solar sail. Is this could be a fantastic way of traveling great distances out in space using a very small amount of energy. And again, this renewable energy source coming from the sun. Now, I've got one last idea to run past you before you mock me and my newfangled future power ideas. And of course, as you might expect, this is idea number 3. Now, idea number 3 is a ion drive. You've probably heard of an ion drive. Science fiction often talks about ion drives or proton drives. And they actually have been around for a really long time. In fact, the idea, the basis would have been around for like 100 years. But we're starting to perfect the idea of an ion drive. And basically, again, it's the same sort of idea, smart car versus drag racer. It's a very small amount of fuel, a very small amount of force, but over time, it can do some amazing things. I draw your attention to this small electromagnet monkey. Now, we all know electromagnetism. And if you don't, I'm going to give you a quick little briefing on it. We have a large positive force on one side of our screen there, and our monkey, for some reason, is carrying a smaller positive force. Now, when two like forces, they repel each other when they get near. Opposites attract, and like forces repel. Well, we can use that process in a very simple type of engine up in space. Now, how it works is, this is a cutaway of how an ion drive works. We have a large positive force off the left of the side of the screen there. We're introducing through an electron gun, an electron, a neutral fuel atom, and
I can't see any of the words.
Is very, very big.
It says magnets, electric gun, electron, neutral fuel atom, and positive atom.
Some of this fuel, and when the fuel is hit by that electron, it produces 2 negatives and a positive atom. Now, that might not sound like much, but there all of a sudden we have the example of a large positive force to the left and a smaller positive force in
right.
our engine bay there. Well, by itself, that's not going to do anything, but it's going to get pushed out thousands and billions and millions of times. So what we're ending up with is a very small action, but over time, and with the amount that are going on, we do get a fair amount of
You can't see
force.
any of the green.
And again, this works really well out in space. You wouldn't be able to use an ion drive down here on Earth. It would just sit there chugging away, not moving at all. But remember, space is a fantastic medium for moving things around. You don't need to worry about aerodynamics. You don't need to worry about drag. So even a small amount of force from something like this ion drive would create a great amount of force out in that environment of deep space. We already use these in space. And in fact, we've used them for quite some time.
So how are you going to travel?
What's changing is the way that we actually utilize that fuel. And in a couple of minutes, I can tell you about a Canadian connection to that.
Obviously,
fuel as well,
there's a Canadian connection. It's probably from
Now,
Vancouver.
we've talked about three possible ideas for powering the future, and some of them might sound, again,
Did he win the
a little
X Prize?
far-fetched. If somebody came to you and said, "I'm going to take an elevator to space," you go, but in fact, this is closer than you might think.
He must
an
have
elevator
won
to
the
space,
X
they
Prize.
have a competition
Google X
for a
Prize.
group of young scientists, people that are coming up with these ideas, and very, very close to us. In fact, a university in Washington
can't see that
State developed a prize-winning space elevator. Now, no, it didn't go into space, but it did raise about 900 meters in the air on its own, on a cable, using a laser drive. And they were actually able to win, they won, I think, close to about $1 million.
Yeah,
no one had
that was
ever
it.
managed to do that before, so they raised
The
this
Google
elevator,
X Prize was it for $1
900
million.
meters in the air. A helicopter was holding onto that, and up it went. And that's the basics of the idea for a space elevator. So again, an idea that might be closer than you think. The idea of solar sailing, well, several countries have been developing this over the last few years. Japan was the last one that had a couple pieces out there, and the U.S. Had one called NanoSail D, which in fact just came back down again from a very successful trip.
NanoSail D.
And you might ask, well, why are they taking advantage of solar sailing now? Because it's cheap and it's renewable and it looks great to the public down here on Earth. Because here you have something like sailing, like people explored Earth hundreds and hundreds of years ago, getting from one continent to the other, and that's basically the idea for doing it up in space. It's a fairly inexpensive way of moving things around, so it looks good for everybody's budget, and it does a fantastic job. And you don't have to worry about introducing any sort of pollution or nasty fuels to all these places that we're trying to explore.
So what you're saying is
And
we're
finally,
hurting the
idea
Earth
of
right
the
now.
Ion drive. Well, there is a company in eastern Canada which is developing a brand new type of fuel for an ion drive system. It's able to extract a lot more power using that same system. And in fact, from their calculations, an ion-powered spacecraft could get from Earth to Mars in about 3 months. Right now, in a regular rocket, it would take about 6. So that's using this new technology to cut that trip in half, which is fantastic. And again, it's using a very small amount of fuel and a very efficient system to move these things around up in space. So there is hope for the future. We don't have to just keep lighting giant fuel tanks on fire and hoping for the best. We can come up with some fairly innovative ideas that will hopefully make space travel safer, which is always great, more environmentally friendly, and a lot cheaper, so that hopefully some of this technology can continue to explore not only out in space, but continue to send things up into space that you and I need, satellites and whatnot, here on Earth.
We don't need those.
In a slightly better way, and feel a little bit better about this.